Okay, we're going to look at something called Converse of Pythagoras. Okay, let's just have a reminder first of the original Pythagoras theorem, which you will definitely have looked at some point in the past. Okay, so Pythagoras theorem states that in a right angle triangle the square of the hypotenuse, I'll just give you a reminder as to what that is in a minute. The square of the hypotenuse, that's hypotenuse, is equal to the sum of the square of the other two sides. Okay, so when you've got a right angle triangle, okay, in a right angle triangle, the side that faces the right angle is always called the hypotenuse. I'm going to call that H. Okay, so that is the hypotenuse. In fact, let's call it HYP. Okay. So in a right angle triangle, the side that faces the right angle is always called the hypotenuse. Okay, and it's always the longest side of the triangle as well. Okay, so hypotenuse, longest side, faces the right angle. Okay, so let's just go over this again. Pythagoras theorem states that in a right angle triangle, the square of the hypotenuse, so I'm going to call that hypotenuse there A, is equal to the sum of the square of the other two sides. So let's call that side B and that's side C. So the square of the hypotenuse is equal to the sum. The sum means you add two things together, of the square of the other two sides. A squared equals B squared plus C squared. Now we're going to go through just a quick example of Pythagoras. Okay, so let's say that side is 3, that side is 4, and that side is x. It's a right angle triangle, so the square of the hypotenuse is equal to the sum of the square of the other two sides. X squared equals 4 squared plus 3 squared, so that would be x squared equals 16 plus 9. X squared equals 25. How do you get x? You take the square root of 25 is equal to 5. Okay, so that's just a quick reminder of Pythagoras theorem. But let's go now to the converse of Pythagoras. Okay, so I'm just going to explain to you how this works as we do it. Okay. Right, so let's say that this side here is 9, this side is 12, and I'm going to tell you that this side is 15. Okay, you can see that this looks as if it's a right angle triangle, but I'm not going to say for definite, is it? So instead I'm just going to ask the question, is this triangle right angled? Okay, now the way we solve this one is if we can get that the square of the hypotenuse is equal to the sum of the square of the other two sides, if that's true, then that means that the thing is a right angled triangle. Okay, so if 15 squared is equal to 12 squared plus 9 squared, then it will be a right angle triangle. So what we need to do is just investigate if that's true. So using your calculator, put in 15 squared, and you should get 225, and then 12 squared is 144, and then 9 squared rather, is 81. It was 144 plus 81, well that is 225. So what we can see there is that Pythagoras worked. 225 is equal to 225. So what we'd say there is left-hand side equals right-hand side. Therefore, triangle is right-angled. And it's as simple as that. Okay, let's try an example 2. Okay, so again, the question is this triangle right-angled? We can tell by looking at it that it looks as if it's right-angled, but what we need to do is prove is it exactly right-angled. So obviously the right angle would be here. So let's try it. And so does that work? 10 squared equals 6 squared plus 8 squared. Well, 10 squared is 100, 6 squared is 36, and 8 squared is 64. So yeah, it worked again. 100 equals 100. So what we would say then is, back to that, LHS equals RHS. Therefore, triangle is right-angled. Okay, let's try an example 3. Okay, so about this one. Right, so you start with the longest side again. So 25 squared equals 24 squared plus 7 squared. Right, you'll need your scientific calculator for that one. 25 squared, 625. 24 squared, 576. And 7 squared, 49. So just check with your scientific calculator. Is that plus that equal to 625? And it definitely is. Okay. So 625 equals 625. So LHS, left-hand side equals right-hand side. Therefore, triangle is right-angled. Okay, let's try an example 4. Example 4, you've got 1.5, 2 and 2.5. And the question is it right-angled? Okay, so that would be the longest side, 2.5 squared should be equal to 2 squared plus 1.5 squared. Okay, 2.5 squared is 6.25. You'll need to calculate with that. 2 squared is 4 and 1.5 squared is 2.25. And that will give me 6.25 is equal to 6.25. LHS, left-hand side, is equal to right-hand side. Therefore, triangle is right-angled. Okay, example 5. That side's 2, that side's 5, and that side is 6. Okay. Is the triangle right-angled? Okay, so let's take the longest side again. 6 squared is equal to 2 squared plus 5 squared. 6 squared is 36. 2 squared is 4, and 5 squared is 25. 4 plus 25 is 29. What we can see is that's not true. Alright, 36 is not equal to 29. So there's the equal sign. Now see the equal sign, if we put a line through it, that then says not equal. So down here we know that 36 is not equal to 29, so let's just backtrack. That is not equal, neither's that, and neither's that. So what I would say now is left hand side does not equal right hand side. Therefore, triangle is not right-angled.